Let's balance some redox reactions. So when we talk about balancing redox reactions, the first thing we have to do is recognize if it's redox. And the key word of oxidation of iron 2 to iron 3 is a very good indication that it's redox. So I have iron 2 plus and iron 3 plus. Dichromate. So we have Cr2O72 minus, and dichromate is reduced to chromium 3 plus. All right, we are acidic. All right, that's important. All right, so let's look at the oxidation. I have Fe3 plus Fe2 plus going to Fe3 plus an electron. The reduction would be Cr2O72 minus plus some electrons going to Cr3 plus. So now we need to look at our rules and we need to balance for mass. For the oxidation, are we balanced for mass? We have an iron 2, an iron 3. Iron's balanced, electrons are balanced, we're good. For the reduction, I have 2 chromiums on the left and 1 on the right. So I definitely need to put a 2 in front of chromium 3. So now I have 2 chromiums and 2 chromiums. Oxygen. I have 7 oxygens on the left, so we balance oxygen by adding water, 7H2O. And then I added 14 hydrogens. Since we're in acidic conditions, I can just go 14H plus, and we got it because we're acidic. Electrons. For the oxidation, our electrons are good. For the reduction, well, I don't even know what chromium is here. So if we look at chromium, chromium would be, well, oxygen's minus 2, so that's a minus 14 equals negative 2 plus 12 plus 6. So chromium is plus 6 to plus 3. So each chromium then has to gain 3 electrons. To go from plus 6 to plus 3, I need to gain 3 electrons. 3 negatives will get me there, right? 6 minus 3 is 3. However, there are 2 chromiums. So I think I need 6 total electrons to make this happen. Each chromium gains 3 electrons to make it 2 chromium 6s, 2 chromium 3s. The next question is, does 6 equal 1? No. So we have to multiply the top one by 6. And then we are going to add these up. I get 6 iron 2s plus 14H pluses plus Cr2O72 minus plus 6 electrons going to 6Fe3 plus 6 electrons plus 2 Cr3 plus 7 waters. And right away we need to check, do our electrons match? And they do. So my net equation would be 6Fe2 plus in solution, because that was in the problem, right? Acidic conditions, we're going to be in solution. 14H pluses plus dichromate going to 6 iron 3s plus, they're in solution, plus 2 chromium 3s and 7 waters. So this is why we have to follow the rules. If we don't follow the rules, I probably will not get that green equation. Number 2, it says balance the following reaction in basic solution. So that means we have OH minus everywhere. Okay, well, oxidation states. If we talk about having OH everywhere, I have OH there, it's not changing, and OH there, so hydroxide's hydroxide, it's not changing. Oxygen is an element by itself, and it just disappears. Wonderful. There's no O's on the other side besides in hydroxide. And iron goes from iron 2 to iron 3. So it looks like my oxidation will be the same as the last problem, the previous example. Iron 2 plus going to Fe3 plus an electron. The reduction, well, that's O2. Now, it doesn't tell us the state symbols here. So there's more than one way to look at this. Well, it doesn't tell us the state symbols. But the reduction, we have O2 plus some electrons, we're assuming, going to what? And that's all we have. Okay. Top one. Top one looks good, except I wrote it this way. I could have wrote it a different way, where we have that if these are solid, we don't know. What if these are solids? Gas, solid. So I could do it this way, or we can rewrite it as FeOH2 and FeOH3. Either way will work. I'll do it this way because this is what I have in the board now. Alright, so the oxidation, is it balanced for mass? No. I can add an OH minus here to balance it for mass. Why can I add an OH minus? Basic solution. Reduction, O2, I have to add water. We have to add H2O. But if I do that, I have to add 2 of them. And now there's 4 H pluses I need to add. The thing is, can I have H plus? No. This is where I adjust for my basic solutions now. And I add 4OH minus to both sides. This becomes what? H2O. 4 of them. Now I don't do anything else. I don't adjust anything else. Okay, electron count. For the oxidation, we're good. The reduction. O2, 0, water, or hydroxide. Water has a -2, so oxygen is -2 there, oxygen 0. So each oxygen needs to gain 2 electrons. Since each oxygen needs to gain 2 electrons, that's 2 electrons, but there are 2 oxygens, so we need 4 total electrons. If we look at our oxidation, that's 1 electron, we have to multiply by 4. Okay, now we are going to add them up. Let's see here. We have 4 OH minus plus 4 iron 2 hydroxide plus 4 waters plus oxygen plus 4 electrons, yielding 4 iron 3 hydroxides plus 4 electrons plus 2 waters plus 4 hydroxides. Okay. What cancels? Well, it looks like our electrons are canceled, which is important, so that's good. Anything else? Yes, it does. It looks like, oh, undo. Looks like 2 of my waters cancel on both sides. And it looks like my hydroxides cancel as well, don't they? So my net equation would be 4FeOH2 solid plus 2H2O liquid plus O2 gas going to 4 FeOH, 3 iron 3 hydroxide, and that's probably going to be a solid. Now, depending on the pH, it could be AQ, and I wouldn't mark you wrong on that. But either way, it works. Number 3. Write the balance equation for the reactions of manganese dioxide, MnO2. We're skip the line. MnO2 with hypochlorite, ClO-, going to permanganate, MnO4- and chloride, Cl-. So chlorine lost oxygen. That's probably reduced. Now, of course, we are in basic solution. Because now you probably realize that for acidic conditions, you just keep it the same. For basic conditions, you have to adjust to get hydrogen ion out if there's any. So chlorine here is, if oxygen's -2, right? So -2, -2, -1. That means chlorine has to be +1 here. Chlorine is +1 in hypochlorite, and obviously chlorine is -1 in chloride. Okay. So my reduction looks like it's ClO- plus some electrons going to Cl-. Okay. Who's reduced? Well, it's probably not going to be oxygen. Oxygen's probably going to be -2. It's -2, -2. All right, so this equals 0, so that's a -4. So it looks like manganese is +4. And I have a minus, add up to -1, -2 times 4, -8, +7. So it looks like we go from +4 to +7. MnO2 going to MnO4- plus electrons. All right, balancing for mass here. The reduction. Have an oxygen, going to add water, H2O. Well, but if I add water, now we're balanced there. H, I need to add 2 H pluses, but we're in basic conditions, so I add 2 OH minuses to both sides. And this becomes H2O, 2H2O. The oxidation, Mn is good. I have 2, 4, so I have to add 2 H2O on this side to get 4 oxygens, and then 4 H pluses. I can't do that, so I have to add 4 OH minuses to both sides. And this, of course, becomes 4 H2O. Electrons. I have +1 to -1, so it's a difference of 2, 1 chlorine, so there's 2 electrons there. And electrons for my reduction, I have 4, 7, that would be 3. Well, 3 does not equal 2. So the reduction needs to be multiplied by 3, and the oxidation needs to be multiplied by 2. Okay. So that's 2 waters times 3, 6 H2O plus 3 ClO- plus 6 electrons plus 2 times 4 is 8 OH- plus 4 H2O plus 2 MnO2. I'm going to make 2 lines here on the paper. We have 3 chlorides plus 3 H2O plus 6 OH- plus 2 MnO4- plus 6 electrons plus 8 H2O. Do the electrons cancel? 6 and 6. Yes. Good chance we're right. Okay, waters. I have 6 and 4 is 10 waters on the left side. 3 and 8 would be 11. So gone, gone, gone. And I'm left with 1. Hydroxides, 8 on the left, 6 on the right. Gone. I'm left with 2. So to redo this, I would have 3 ClO minus in solution plus 2 OH minus in solution plus 2 MnO2, which is probably a solid. If you put AQ down, I'm happy at this point. So I'll make you know that. 3 Cl minus plus 2 MnO4 minus plus water. And I do expect you to know it's with the water. That's better. There we go. There's number 3. And again, if I don't follow the rules, I'm not going to get this done. Unless you have it memorized, there's no way to look at that and say, oh yeah, it's definitely 3 hypochlorites. There's no way to do that. All right. Now number 4, last one. Oxidation. Good chance that there's a redox reaction. Oxidation of oxalate. So we have C2O4 2 minus. And we know this is getting oxidized by MnO4 minus. Produce MnO2 and CO3 2 minus. Okay, so we know our ox is going to be C2O4 2 minus because it said so. I'm going to CO3 2 minus plus some electrons. And we know our red is going to be MnO4 minus plus some electrons going to MnO2. Take a pause at this for a second and look at that reduction. Does it look like this oxidation, MnO2 going to MnO4, it's going to be very similar, right, to MnO4 going to MnO2, except we're going to be backwards. But we'll still do it, but it should look like the same reaction. All right, oxidation. Let's do our oxidation states just in case. So oxygen, -2, -2, -2, and -2. Not changing. So equals -2. It's a -8. So that means this is a +6. -8 plus 7 equals 0. -4 plus 4. And -2 minus 6 plus 4. Okay, so my reduction here, I go from +7 to +4, which we thought, which was a 3 electron that we had above, same one. And my oxidation, I go from +3 to +4. All right, perfect. Now let's talk about the mass here. So carbon, I need a 2 in front of carbonate. That leaves me with oxygen. And for oxygen, I need 3 times 6 and 4. I need 2 waters. All right, so now I have 2 and 4 is 6 and 6. But now I have 4 H pluses, which I can't do that. So we're going to add 4 OH minus to both sides. There. Now electrons. Each carbon's gaining one, or losing, excuse me, each carbon's losing one electron. And there's 2 carbons, so that's definitely going to be a 2 electron transfer. Okay, manganese down here. Manganese is balanced, oxygen is not. I need to add 2H2O on this side, but then I have to add 4H plus and then 4OH minus to both sides. And this becomes 4H2O. Add them up. Let's see what we get. Now, before we add them up, I almost forgot. Does 3 equal 2? Not usually. So the top oxidation has to be multiplied by 3, and the bottom reduction has to be multiplied by 2. 3 times 4, 12 hydroxides, plus 6 waters, plus 3 oxalates, plus 2 times 4, 8 more waters, plus 2 MnO4 minuses, plus 6 electrons. There is my left-hand side. Right-hand side, 3 times 2 is 6 carbonates, plus 6 electrons, plus 4 times 3, 12 waters, plus 2 MnO2s, plus 4 H2O, plus 2 times 4 is 8 OH minus. Do our electrons work? Yes, they do. 6 electrons and 6 electrons. We're off to a good start. Hydroxide, 12 on the left and 8 on the right. 8's gone, down to 4. Water, 6 and 8 would be what, 14? 12 and 4 would be 16. So the 6 and 8 are gone. 12, I'm left with what? 2. I think that's it. So the net equation would be 4 hydroxide in solution, of course, plus 3 oxalate, C2O4, 2 minus. Anytime you have an ion by itself, it's going to be in solution. Plus 2 MnO4 minus, going to 6CO3, 2 minus, plus 2 MnO2, that's a solid, plus 2 H2O liquid. There we go. So there's 4 examples of balancing redox reactions into various conditions. 1 acidic, 3 basic. You just follow the rules, follow the guidelines, and you can do it. You have to do each step. So if you're like me and very impatient and want to just get it done, it's not going to happen. You gotta follow each step in the procedure. All right, I know you guys can do it. Hopefully that helped balance redox reactions, and we'll see you in the next video. Take care, guys.